Hello everyone, in this video we're going to solve some problems involving doing basic arithmetic operations and data types. So let's start with the first problem. It says approximate area of a circle. Now consider a circle with a radius of 8 meters. Calculate the area of the circle. And there's a hint which says use the variables for representing radius, pi, and the area. Now let's set those variables up. So what is radius? Well, radius is given as 8 meters, but actually in Python you can't say meters, but you have to note it down for the sake of the next developer who's going to read your code. Like at first sight, what is it? 8 meters, 8 centimeters, 8 kilometers. So we have to clarify those kind of things in our code. And then moving on, the value of the pi is usually stated as 3.14, but depending on the use case, the preciseness of this value can change. So you can actually write 5 digits of this decimal. And then we have the area. For finding the area of the circle, we obviously have to multiply pi multiplied by the radius squared. Well, to show the square operation, I used 2 star mark. This shows the power. So if I type 5, it will multiply radius by itself 5 times. So it's pretty useful operator, since it reduces the number of times you write the same sign over and over and again. So now that we have stored the value of the area, which is meters squared, in the variable of area, we need to show that to the user. So in order to do that, we need to use built-in function of the Python, which is written as such. The print inside, we need to say the area is, well, area. Now here, because this is a variable, the program is not going to print area here. Instead, the program will print the value which is stored in the variable of area. For example, if the value of the area variable is 5, well, it will say 5 instead of area in this place. And add meters squared. So let's run the program. See what's going to happen. Well, let's zoom it in. Well, the area is 200.96 meters squared. Now let's continue with the second question. The title says animal legs. There are 20 animal legs in a garden, and 4 of those animals are chickens and the rest are cows. Write a program that calculates and prints how many cows are in the garden. So I want you to stop the video and think of that solution on your own. Well, here what we need to do is to do some bunch of arithmetical calculations, arithmetic operations. So we're required to find the number of cows, right? So we have the variable for total legs in the garden, the legs of chicken, of course, like legs of each chicken, one chicken, not all the chickens, and legs of one cow, and the number of all chickens in the garden. So the only information we don't know is the cows, the number of total cows. So that's what we need to calculate now. So in order to find that, we need to find the total number of cow legs in the garden. So how do we find that? Well, there's a total legs, as we're given, legs total, minus the legs of all chickens in this garden. How can we find that? Well, we basically can multiply the number of chickens by the number of legs in each chicken. Like 4 chickens, each having 2 legs. Well, in total there are going to be 8 chicken legs. So with the same logic, we can multiply those variables multiplied by the chickens. Now, if we subtract the total number of chicken legs in the garden from the total number of legs, we'll be left with cow legs only. But we are required to find the number of cows, not the legs of cows. So what we're gonna do is to divide the number of all the legs, the cow legs in the garden, by the legs of each cow. So how it's gonna be like? Let's divide it by legs of cow. Now here it is important to use parentheses. Why? Because the Python, just like in the real world mathematics, actually obeys the law of precedence. What is it? Like, it actually cares about which sign should be calculated first. So if you don't put any kind of parentheses here, the Python will first multiply those and divide that, and then subtract the value got here from the legs total, which is definitely not the thing we were looking for. So we put a parentheses to prioritize this part of the calculation, and then divide by this value, which actually does what we want, to divide all the cow legs in the garden by the legs of each cow in the garden. So let's print the number of cows. Well, now let's run the program, see what's going to happen. Well, it says invalid syntax. Why? Yeah, we forgot to put a comma here. Okay, now here we got the answer as 3.0. So we have a useless decimal part here. Since the number of cows should always be integer, we don't need a decimal part in this number. So what we need to do, because we did a division operation here, the Python automatically converted this data, the number of cows, into a floating point number. What is floating point number? In floating point number, there's actually a point in the number, and regardless of it being integer or decimal, it always has this point. So in order to get rid of the point, we need to convert it into integers. So we know that cows should be integer, and then we can safely write int behind this variable. What it will do is to convert this into an integer value. Now if I run the program again, this will give me a better answer. Like, there's no decimal or whatsoever. Now let's continue with the third question. The question asks, the speed of the rocket was initially moving at 50 kilometers per hour, and after 30 seconds the speed of the rocket became 20,000 meters per minute. And what was the average acceleration of the rocket in SI units? Well, we're given the SI units and the formula, and there's a hint saying use the separate values due to representing rocket and acceleration for conversion and calculation purposes. Well, I urge you to stop the video here and think about this on your own and continue to see the solution. Now, first things first, as you can see, there are a lot of things that are messed up, like 5 kilometers per hour, meters per minute, and none of them are SI units. So we need to have a lot of conversion around here. So let's just note the first things first, and just 30 seconds. Let's note that out. Time equals to 30. Wait. 30, type seconds, because it is what it is. And then let's do a strategy called divide and conquer. So what is it? So because the things are so complex around here, we need to divide this into small sections of problems and solve those small problems and apply them in the big picture. So first we need to, what's the first variable we're going to take is the initial speed, 50 kilometers per hour. So we need to consider that initial speed. Well, firstly I will create a raw initial speed variable. What is it for? Now 50 is not it's not converted, it's not useful right now, but we can actually make it useful after doing some processes on it. So the initial speed in the raw form is 50 kilometers. Put some space around here. Yeah, kilometers per hour. Well, this in itself means 1,000 meters per 3,600 seconds. Well, now let's create a variable called initial speed and use raw initial speed to convert it into the SI unit. So how I'm going to do that? Well, I will multiply raw initial speed by 1,000 and divide by 3,600. And the units of this is going to be meters per second, just like in the SI. And then we will create another, we will consider second variable. The second variable is the final speed, which is 2,000 meters per minute. So let's say final speed. Notice how we separated the calculations made on the initial speed from the final speed. And the final speed, the raw final speed, is what we need, is actually equal to 2,000. Well, I need to add meters per minute, which is equal to meters divided by 60 seconds. Well, now that we have the raw final speed, we need to convert it into the SI units. So to do that, I'm going to create a variable called final speed, and that is going to be equal to raw final speed multiplied by 1, since the meters is meters. We don't need to change anything here. But minute is 60 seconds, so I have to divide it by 60 to simplify that, this part, and turn it into meters per second, just like in the SI. And yeah, the last step left, which is the acceleration, we just found the initial speed, the final speed, because we need to find the change in velocity. Now it's time to find acceleration. Well, now we know the time is 30 seconds, right? We just need to find the change in velocity. Change in velocity. This is the name of the variable. And what's the value of change in velocity? Well, it is final speed minus initial speed, which is, of course, again, meters in meters per second. And that is just like how it's given in the SI units. And in order to find the acceleration, we create a straightforward variable name, which is acceleration. And the acceleration, the formula of the acceleration is given here. Change in velocity and the time. And then there we go. Because everything is standard, everything is in SI units, the acceleration, the resulting value is also going to be in SI units, which is meters per second squared. Now that we have the value of acceleration, it is time to print the value, and we're gonna say acceleration and then put an empty place here and a comma. Oh, wait. Yeah, and then acceleration, comma, and meters of second per second square. Well, let's try it out. Let's see what's going to be the result. Well, the result is, oh, sorry about it. Yeah, the result is approximately 10.65 meters per second squared. And you can actually try it on your own to confirm that if it's true or not. It's actually true, but yeah. And what's the best part of writing code in that style? So the question is given in such a way, but we made the program flexible so that in the future, if the question says after 15 seconds, not instead of 30, and saying rocket became 30,000 meters per minute, and we can actually just change some values here and our answer would be right. Like after, instead of 30, it's 15, let's say 15 seconds, and the speed of the rocket became 3,000 meters per minute. So let's find it out. The raw final speed, well, it's just 30,000. Well, what would happen now? Well, if I do that in that way, we'll get another answer, which is also correct because everything works according to a formula. So this is the advantage of writing flexible code. See you soon.